Morning, everyone. I'm Eric Yen, one of the co-chair of the Cloud Working Group. Welcome to the first session of APAN 56, the Cloud Work. Two sessions today. As usual, thank you. Yeah. Please find a seat. Yeah. The Cloud Working Group, we have three co-chair. We have two other co-chair will join today's meeting remotely. One is Professor Jo-Wan Kim. Maybe most of you know him. He's from GIST from Korea. Another co-chair of the working group is Professor Kawashiwalaki from Kindai University of Japan. I'm sorry, I didn't show the exact presentation title of Hiroki's talk. So in the first session, as usual, we have the some kind of case study sharing from the participant or from the co-chair. So in the first session, we have three presentation co-chairs started from me. In the second session, in today, so we hope that we can have communication with the participant, no matter you are in person here or in the Zoom participated remotely. So we can have discussion about how to work together. For example, if you like, you can share your requirements, yeah, sure. You can share your cases in your institute or in your country, or you can provide any suggestion or comments to the arrangement for the future meeting. So that's about the two sessions today. So if there's any comment or suggestion for today. Yeah. The Cloud Working Group in APAN was started from about 2015, according to my memory, or earlier. So in the beginning, we aim to supporting the, of course, the science community or academic applications in Asia, among Asia partners, to make effective use of the available resources from the partners. We also like to bridge the user community with the service provider or the application support resources from the partners, so that we can work together for better use of the available resources, for sharing of the experiences from partner, or for working together for larger problems. We also found that the case study approach might be useful by sharing the how to deploy the cloud technologies for solving what kind of problems, making use of what kind of approaches, something like that. So in the past almost 10 years, we've been sharing case studies in almost every APAN meetings. So we also like to build up a kind of category, a list of available resources from all APAN partners, including the services, such as including the data, tools, cases, anything which is available or open access to everyone. And we also supporting the some kind of coordinations from the requirements of some teams or the user communities to develop the proof of concept experiment. Yeah. By coordinating the different resources with the users. So in every APAN meeting, we can review the progress in the past and see how to go in the future. So that's about the plan, and also the model of this working group. Of course, your advice are also welcomed, so that we can to improve the objectives, or to improve the collaboration models of this working group. So in the beginning, I like to share the progress in Taiwan, making use of the cloud for supporting the science in my academy, Academia Sinica, and also the experiences from some collaborations we've been participated. So I'm Eric Yan from Academia Sinica Greek Computing Center in Taiwan. So the AAGC, we've been supporting the research computing, not just in my institute, but also in the whole academic in Taiwan. My center started from joining the WCG, you know, the worldwide collaboration for searching for the Higgs particle, one of the largest high energy physics experiment leading by CERN in Geneva. So we are acting as a tier 1 center of the Large Hadron Collider experiment from early 2000. And based on the technologies we learned from WCG, so we extended the infrastructure, the technologies to support other disciplines beyond high energy physics, not just in Academia Sinica, but also to the other universities in Taiwan, and also to our partners in Asia. Some of the examples will be explained in my slides later. So as you can see here, that we've been supporting different scientific applications from 2006 based on the same infrastructure. That means we learn the core technology from the WCG and build up different services for different scientific applications. So we build up the research infrastructure, platform, and services, and also those facilities are improved progressively along with the collaboration with different user communities. About 10 years ago, we have a big data project inside our center. That's for the system efficiency optimization, covering the power, thermal in the data center, and also the system applications for the user services. So that's also very important goals of our centers. And from this year, we have some funding supporting our center as the core facility for big data and scientific computing for Academia Sinica, and also for the Taiwan. Of course, as part of the Academia Sinica, that's the research institute for the basic science. So the goal of our center is to supporting the discovery and innovation from the user community, from different academic groups. So as the first slides, our center is coordinating the different resources based on the user requirements. So now the supporting for the data intensive scientific discovery has been almost the largest user needs or applications of our centers. So of course we also have to supporting the machine learning enabled scientific applications for our users in Taiwan. So this is, I try to summarize what we are doing. The circle in the left-hand side, that's about the workflow of the user community. Typically, what the requirements of the whole workflow of the users of our users. So we've been working together for a number of particle physics experiment listed here, not just the others at CMS from the Large Hadron Collider, but also AMS, you know, the detector in the space station, and also the gravitational wave projects, the neutrino projects, the ice cube, the proton therapy, etc., and also several other physics applications, including the condensed matter, the material quantum fields, biophysics, etc., and also computational chemistry, biomedical, such as the structure biology, proteomics, drug discovery, bioinformatics, earth science, astronomy and astrophysics, and also ecology, etc. So in the lower parts in brown, that's about the core components of our services supporting those scientific applications, including the infrastructure for the computing, storage, and the networking. So we also support the data services, as I mentioned, and also the authentication and authorization, how to supporting the user to easier access to the services, no matter the who are providing the resources. The services might not coming from AIGC directly, could be also coming from other universities, other partners in these collaborations. So we also supporting the web-based application environments, for example, using the Jupyter Lab, which is quite popular right now. And also we build up the customized web applications, and of course the machine learning frameworks. We also providing training for our users in Taiwan. That's the summary of what we are doing. So here are some of the examples. Taiwan is part of the KAGWA and also LIGO experiment in the gravitational wave researches. So now the three primary experiment of the gravitational wave in the world now integrated based on the same computing infrastructures. They call it IGWN, International Gravitational Networks. So now we've been part of the my center because we are supporting the big data processing. Now we've been joining as one of the member of the IGWN collaborations. Here are the examples for the protein structure analysis in the lower parts, lower right parts. That's the we are collaborating with the cryo-EM facility in academia Sinica, so that the users get their data from the cryo-EM facilities. The user no need to download his data and upload to some data center to do the data analysis. So we build up the on-the-fly data management systems. So the data could be transferred from the cryo-EM facility directly to the analysis facility in our center. And then user just open the web page, and then he can finish all the analysis he needs using the software he needs, right as the software and data is set up in his own computers, without download and upload anything during the course. So that's we are doing for the integration of the data analysis workflow together with the cryo-EM facility supporting the protein structure data analysis. In the upper right parts, that's another using another facility for the protein structure data analysis. That's experiment at the single center using a beamline TPS 13A in another center about 100 kilometers away from our center. So the logic is very similar. The data could directly transferred from the single zone center to the to our center for the analysis. Then user could just adjust the parameters and finish the data analysis in the cloud in our centers and just download the results back. And about 3 years ago, we've been setting up the AlphaFold, like this one, according to the requirements from our users, so that the biologists could also reference the simulation results from the AlphaFold. I have another example here. This is a paper just published probably last month. So the user built up by himself, a scientist, biologist, built up a virtual solution for rapidly and cost-effectively design of the functional modulator of the some kind of enzyme, making use of the tools such as AlphaFold and also Rosetta Fold, using the diffusion model or something like that, supporting the whole process, started from the sequencing, design, the gene synthesis, etc. To understand some, for example, a very large sequence of protein structures and how the this new protein could interact with other protein or with different modulators in this design. That's a very good models for the scientific applications. And here's the details of the collaboration model with the synchrotron center. So we build up the web portal for the users according to the design by the synchrotron center. And this is the details. The yellow parts, that's the workflow in the synchrotron center. And so we're supporting the data integration between the synchrotron center and the computing center in academic center. The other application domains, such as the earthquake application. So you know, in Taiwan, we've been built up more than 700 seismological sensors in the schools, from elementary schools to junior high schools. So every 5 to 10 seconds, the sensor will send back some data, and more data will be coming back to the server once there's any earthquake happen nearby. So our center is now supporting the server to collect the data from all the hundreds of sensors around Taiwan. So here are the photo of the sensors. That's this one, very small, and that's the case out to once the earthquake data has been collected, some earthquake event happened, then how the data analysis could be accomplished on the fly and deliver the analysis seismic map like this one. The other new project in the right-hand side, that's making use the fiber to detect the seismological signals. Bury the fiber underground. Yeah, that's a new project. Again, our center is serving as the data collection and also the data analysis for this project, and because of the quite a huge amount of data collected from the fiber as a sensor in this purpose. And here are more examples about the disaster mitigation. If you are interested in the details, and welcome to join the session on Wednesday, 11 a.m. in this week. Because we are also acting as the coordinator for the disaster mitigation collaboration in Asia. So the first case is the Typhoon Haiyan case in Philippines. So together with the scientists, so we successfully resolved the problem to numerically simulate the lowest pressure and the strongest wind speed of a super typhoon That's quite hard before. And then, so based on these results, the simulation model and the simulation portal could be used by users or by other events in the future in different countries for different typhoon. Yeah, that's the case. And based on that, so we also working together with the satellite user community or satellite centers to make use of the Earth observation data to follow up the development. For example, the development after the natural disasters. Yeah, that's just one use case. Yeah, because yeah, more supported research of our center summarized here. For example, the proton therapy cases. That's also based on the high energy physics scientist group, the neutrino, the yeah, astronomy, and also the gravitational wave. Yeah. So as I mentioned, some of the user community, especially the life science, and also the disaster mitigation or the humanity and social sciences, they prefer to have the turnkey systems, just making use of the web browser. So we supporting the web portal. We call it web applications. So for each square here, that's the different applications. And there's the color bar showing the resource status of these applications. In the right hand side, that's the Jupyter Lab, right? And also, we also supporting the web terminal. You would prefer the command mode interaction to the data analysis workflow. So based on the computing, storage, and networking, we're supporting the machine learning framework, PyTorch, Keras, etc. And we also integrate the CPU resource, GPU resource, and also provide the containerized application packages for the users according to the data analysis workflow from the user communities. Yeah. So in the past few years, we've been developed more than 50 web applications for different purposes listed here. Another thing is that, maybe EGI. If you like to understand the details, there's the UI of this institute. That's the European funded eScience in the beginning, in the 20 years ago. Now it's aiming for the open science because of the strategic direction from the European Commission. So the EGI, very similar to what we learned from WCG. They are providing the open science infrastructure for the whole Europe, and also collaborating with the whole world. So our center and also some Asia partner has been part of the EGI collaboration about 15 years ago. So now EGI is making use of the Kubernetes, Jupyter, and also the user communities from the Europe, providing the binder and also the repository services for supporting the open science. That means users are very easy to access to those notebooks, which are shared to the academic. And also you can access the algorithm to the data provided just from the services, just making use of the Jupyter notebook. So that's a typical examples for how to supporting the open science. There are many other things, yeah, especially from the beginning, we learned from the open science initiative for the user community or for a project. The first thing is that every project needs to have its own research data management plan. If you like to be part of the open science project. So that's what we learned. You probably know that there are the FAIR principles, yeah, how to support in the open science from the beginning. That's the baseline for example, the criteria for the data and also for those resources you like to share. So that's in Taiwan, we are supporting these different collaboration models. For example, the users who easier access to our resources because we are asked to user has to pay for the services from our centers. So very similar to those commercial cloud. That's the pay-as-you-go model. And we also supporting that the user could providing the hardware money and so that our center could integrate the hardware with our infrastructure together and share the hardware to all the users. That's another model. We also welcome the user providing the services developed from the user communities, if that's also agreed to share to everyone. So we can have new services. We turn in the requirements into new services, and new services will coming in along with the new scientific collaborations. Yeah, that's a kind of continuous growth models of these collaborations. And of course, we also supporting the development of the advanced or customized services. So that's some because of the time I have to switch to the second speaker at exactly 9:30. Yeah, so I might skip here for the rest of my slides, including the supporting machine learning enabled data analysis. If you are interested, we can have discussion in the second session. And for the machine learning application, we're supporting various GPU models, including A100, V100, 3090, and also the framework. And there are also some of the use cases. That's a very simplified system diagram of how we supporting those scientific applications. The left-hand side, that's the conventional computing models based on SLAM. I think most of scientific computing users, they are familiar using SLAM. The right-hand side, that's the cloud services. So we integrate resources, heterogeneous resources from different hardware from different institutes. Yeah. So in the regional collaboration, I think, as I mentioned in the beginning, the objective of the cloud resources. So if you like to share, or if you like to share a resource or a case study or anything, you are very welcome to join the cloud or working group in the future. Yeah. This is our data center. Yeah. Sorry. Yeah. The last slide. So as a summary, yeah, typically the cloud services for eScience, they need the single sign-on. In APAN, we have the IAM working group. They could support the such single sign-on services based on again. Yeah. So the deployment of either virtual machine or container deployment. So the cloud working group could work together with you, and also the infrastructure partners together. The application sharing, yeah. So we can learn from the open science projects from Europe or from other projects around the world, and to work out reference criteria or workflow for our partners. We have the open and sharing working group in APAN. They try to define some kind of white paper or the guidelines for the data sharing. And of course, to prove the concept, we can also work together with the users to implement the workflow, making use of the resources from partners, and also deploy some advanced application environment, etc. So that's my presentation today. Yeah. Any quick questions for everyone? Otherwise, I have to switch to the next speaker. Yeah. Yes, please.
I'm a Japanese.
Yes.
And, are there any Japanese organization who participated in these activities led by ASGC?
Yeah. Like Kagwa. Kagwa, we are working together with the University of Tokyo.
University of Tokyo.
Yes. For the higher education WCG, we also working together with KEK, with the Tokyo University. Yeah. For the cloud services and also the computing infrastructure, we have very good collaboration history with the NRI in Japan. Yes. For the AAI, we also working together with NII. Yeah. So in this week on Thursday, we have the AP GRI PMA meeting. Yeah, that's the X509 authentication framework. That's a global trust framework. So we are part of the global trust. We have another meeting there. Yes. So yeah.
Which, for example, are there many projects who work with United States or European organizations?
Yeah, gravitational wave high energy PC. Yeah, that's based on the user community. Yes, yes,
high
sure.
Physics.
Yes, yeah.
Thank you.
Yeah, thank you so much. I think I have to switch to the next speaker. So, how should I do? Stop sharing. Okay. John. Oh, he's not alive now.
Wow.
Wow.
He's only available at 9:30. Yeah. So Hiroki, are you ready?
Yeah. Okay.
So he has to share remotely. Yeah. So please share your slides if you are.
Okay, thank you very much. Wait a moment. Oh yeah, share the keynote. Okay, can you see my presentation slide?
Yeah, very good.
Okay.
Go ahead, please.
Okay, thank you very much. And so I usually speak at APAN's cloud working group about Dist Cloud, and I usually title is Dist Cloud update. But by the way, today, Dist Cloud is a wide area distributed platform in Japan, constructed by us. But by the way, today, this time I'd like to talk about a research and development project sponsored by the National Institute of Information Communication Technology, also known as NICT in Japan, as an application example of this cloud in these days. Okay, now let's talk about resource transparent wide area distributed computing environment with a functional paradigm in the beyond 5G era. In the era after 5G, which is the Japanese Ministry of Internal Affairs and Communication, also known as MIC. Wait a moment, sorry. Specifically called Beyond 5G, the Japanese government is promoting research and development of Beyond 5G starting in 2020. Our group's research proposal has been accepted for the Beyond 5G commissioned study in 2021, which is overseen by the National Institute of Information, NICT, our research and development organization under the MIC. In fact, we have tried several times to bring Professor Takase and the leader of the research group to the APAN Cloud Working Group meeting to give a presentation. But by the way, so unfortunately, we are unable to match the schedule and budget to invite him. In fact, we had an accident in 2023 when the budget of this research project was cut by 40%. Yeah. And we are told that the cut was not only for our research proposal, but for all the research projects selected for this commissioned research. 2023 is the final year of this research project, and we are still struggling to make ends meet with a meager budget. I'll share my budget-related grumblings with you sometime in the future. Okay, and this slide is a schematic of our research and development project. The term functional paradigm is used in this title. We are focusing on the use of functional languages, which is a paradigm in programming language. Why functional language, and why is the programming language paradigm relevant to R&D in the Beyond 5G era? Okay, let's explain what kind of platform is needed in the Beyond 5G era to allow a variety of processing to be performed on the rapidly growing number of devices running on any operating system. So functional language have some kind of the image of being difficult to write and intuitive. Indeed, functional programming language such as OCaml and Haskell are very hard to learn. And the open source libraries developed by the third parties are not plentiful. In the Beyond 5G era, it is said that the number of devices will increase overwhelmingly. These devices include, of course, mobile devices such as a cell phone, but however, mobile devices will be not rapidly increasing in the Beyond 5G era. The biggest demand for connectivity that is not currently connected to the 4G or 5G network is actually in factories. Factories that produce industrial machine or anything else. In a factory, there are between 100 and 1,000 robots, very simple robots operating in a single manufacturing processes. Depending on the size of the factory, there are 10 to 100 or 1,000 manufacturing processes per factory. Wi-Fi is not an appropriate infrastructure for factory networks, both in terms of wireless coverage and in terms of the number of devices that can be connected in one access point. There have been trials of broadband wireless access, also known as local 4G or BWA, and local 5G in the past. But the expensive, very expensive access point and the need for national radio operators license have prevented widespread adoption. So now all of these robots run a robot operating system, or ROS, which is a very simple single task, single thread operating system, rather than less rich modern operating systems such as Linux. When we exchange messages on such an OS, for example, using the publisher-subscriber model, what language would be better to write the platform in which the service is run? Okay, here Python or Java not to be better choice for a platform based on very poor CPU resources, memories capacity, and simple OS mechanisms. In fact, it is even impractical. This is where functional language comes in. As mentioned above, functional languages have a high degree of difficulty in writing programs, but their execution environment is extremely compact. Functional languages are characterized by powerful concurrency, not the parallel processing implemented in Python or Java, but concurrent processing. Concurrency is realized in lightweight threads, which are different from parallel processing threads that depend on the number or physical cores in the CPU. In the beyond the 5G era, we expected that the number of device access per access point would increase dramatically, and that the price per access point would become more inexpensive, and that there would be demand for a variety of processes which would require supply to handle. So we choose Elixir, a programming language Elixir, a functional language based on ARM, which has become popular in the last decades because its syntax is very similar to the programming language Ruby. It uses Beam, B-E-A-M, Beam, Alan's processing system, and can easily handle lightweight processes, and can easily handle lightweight thread. Yeah. The problem here is that when a device wants to outsource its processing, and it is difficult to solve which device to outsource the processing to. And therefore, we decided to translate the distributed key value store KVS architecture that our research group had developed 10 years ago. This distributed KVS was implemented in Java. So one of our goals was to re-implement it with Elixir. By using the distributed KVS, each device can request and use computing resources without procedure of searching or consigning devices. Finally, using the distributed KVS, it is necessary to implement a decision-making resource and response. So to implement a decision-making algorithm that assign any appropriate computing resource to a request for computing resource and responses. This is a configuration of the platform that our research group believes will solve the problems of the beyond 5G era. Okay, and so next slide, yeah. And our group consists of the 9 researchers involved in this research and development. Professor Nakagawa from Osaka University, the author of the original distributed KVS system. Professor Kikuchi from Kochi University of Technology is a consultant with the industrial IoT system. Mr. Osaki and Nishiguchi is currently running an R&D venture company in Kochi Prefecture. And these 4 are in charge of research and the development of a resource transparent distributed processing system. And so second, so Professor Takase and Dr. Hosoai from the University of Tokyo and Professor Okawa from Kumamoto University are in charge of the development of ARM's beam processing system for the system on chip SoC and the development of Elixir middleware for the actual 5G environment. And so third, so Kashiwazaki is designing and implementing the decision-making algorithms for computing resource requirements. Finally, Mr. Kikuchi from Sakura Internet Research Institute is in charge of developing the killer application in the beyond 5G era. But by the way, so however, we are still trying to figure out what the killer application will be. Okay, and so the outline is as I have described it so far, but I would like to talk about the additional one thing about the local 5G testbed. Yeah, and our research and development demonstration create a small testbed for local 5G. So I don't know how widespread local 5G is in your country in the cloud working group. At least in Japan, it is not so good situation, and not so very popular. Yeah, and only the very few. I only guess that there are about 10 to 100 research institutes in Japan that are procuring very expensive equipment for research and development. In this case, we installed a set of local 5G base stations and our other equipment at the Kochi University of Technology. In fact, NICT, the sponsor of this R&D, also has a local 5G testbed. This testbed consists of 3 locations: Tokyo, where NICT is located, and Osaka University in Osaka Prefecture, and Kyushu Institute of Technology in Fukuoka Prefecture. Yeah. And so Kochi University of Technology is considering connecting to these using JGN, a research network provided by NICT. We also plan to connect to SciNet, a Japanese academic information network provided by NII. In order to connect to this cloud and our wide area distributed platform in which we are continuing our research and development. Yeah. Okay, and in order to set up local 5G base station, it is necessary to prepare a group of computers running software called 5G core. And in addition, a GPS antenna must be installed to record the exact location of each base station and the local 5G access point. These enable the operation of local 5G base station. The initial cost alone is roughly 100,000 or more. Very, very so expensive. Yeah. As already mentioned, unlike Wi-Fi, a radio engineering license is required to use the 5G signal. In addition, the strength of the signal must be controlled to ensure that the local 5G radio coverage does not interfere with other 5G or local 5G networks. In addition to interference, the signal strength must be controlled so that it does not cover outside of the facilities owned by the individual or entity installing the base station. This is a very, how can I say, it's a very hard work to satisfy this kind of the coverage limitation very much. As already mentioned, so here is a map of the area near the Kochi University of Technology installation site. While measuring the radio wave, check for any radio wave leakage outside the premises. And this is what it looks like when radio waves below 100 decibels meter are also displayed. It is this is less than below 100 decibel meter are also displayed. It is important to accommodate the yellow to red cell within the site. And this is the actual local 5G antenna installed on the top of the roof here. And it is installing on the top of the building on the 3rd floor of the atrium structure, and is designed to allow the local 5G signal to reach the 2nd floor and 1st floor as well. And currently, we are connecting the virtual IoT devices to local 5G, which is then connected to SciNet, and from there to Sakura Internet and AWS, which are public cloud providers, for offloading to the cloud, and multi-purpose edge computing MEC. We are now in the process of uploading to the cloud and separating the cloud from multi-purpose edge computing resources. Yeah, that's all. And okay, that's all my talk about our research project about the acting against the beyond 5G era, and so using with the dist cloud our research activities very much. Okay, that's all. And any questions?
Yeah, thank you, Hiroki.
Yeah.
Any quick question? We can take one. Yeah. Andrew. Yes.
Source the 4G access points from.
Yeah. Hiroki. Yeah.
G access points from very accessible market, which they are very expensive.
Would you be able to share some of the prices with us?
Oh, your question is about the who can access to this local 5G test bed or anything else?
Where did you actually purchase
Okay,
the
yeah.
IPs?
Oh yeah. So I think so to use or to connect to the local 5G equipment, so we need to some kind of the SIM physical SIM card installing to the mobile phone, so cell phone or anything else. And this SIM card is connected to the device ID, and who will use this device and some kind of the individual information. And without the set of this kind of the device ID and the individual information to the MIC, Ministry of Internet Affairs and Communications, and then so these devices, as a combination of the devices and so individual can be allowed to use to connect the exact characteristic access point. So because of this kind of the very complicated allowing process, it is a very hard. It is not so free to access this kind of the point. Only the allowed person or only the project member can access this kind of the local 5G environment or anything else. This is so, it is only the, I think, demonstration site, and it is very hard for us to public demonstration such as a live demo and with some kind of the audience or anything else, unfortunately. Yeah.
Thank you. Yeah, because our second speaker has been online. So let's switch to Jongwan from Korea first. And then if there is still time, we can back to the discussion. Yeah.
Okay.
Jongwan, would you please share your screen?
Can you hear me?
Yeah, we can see you. Please, slides.
Okay. So can you see my screen?
Yes. Would you please turn into, yes. Yeah, it's good. Okay. The floor is yours, please.
Okay. Yeah, thank you. Yeah, sorry for not meeting the time. And this is Jongwon Kim from Korea. Unfortunately, I cannot be there. Yeah, due to some kind of event conflict. Okay, here I'm attending Korea Supercomputing Conference, and then so it's a two events kind of at the same time. It's unfortunate. Anyway, let me begin my talk. This titled, Cloud Native Data Center Computing for Live Express AI Services. I'm kind of talking about this topic, cloud native and data center computing, for some time. This time I want to update that how some kind of structure being kind of coordinated to better utilize, better enable this kind of computing thing. Okay, let me begin. So I've been talking DNA thing. Basically, this is the Express AI because D as a specific domain data and N networking will be kind of cross effect to AI. So A here means AI. So let me show the picture. Okay, before I jump into this Express AI or DNA data networking and AI thing, everyone know AI is really getting our attention, right? So it's been weak, but it's getting stronger. Yes. And then we've been kind of hearing a lot of large language models kind of stories these days, right? LLMs. So here, data-centric AI, hyperscale, large language model AI, and also responsibility of AI is becoming really important. So that's the main trend regarding AI. So Express AI is basically talking about domain data X will be connected to AI, right? So basically please try to interpret X plus AI domain-specific data. D will be connected to AI, right? It's DNA, data networking AI, and X plus AI, basically the same thing. So let me just kind of briefly remind you about the training and inferencing kind of, asymmetry thing. You have to train for the AI model creation or retraining of those. You have to utilize a lot of big size data, right? That will take a lot of, say, computing power, which is of training. But on the contrary, inferencing will need smaller ones, right? Because you will only try to utilize your AI model already pre-trained and already kind of say built. It's like a say summary note for your exam. So it's inferencing is a kind of you take the note, basically your AI model to the exam, and you utilize it. So basically, training and inferencing it's not happening at the same scale. It's different, right? So, but what's really becoming important? So you may train with a lot of data with good, very good summarization, which is the AI model. But in fact, what AI will get the value only if you can utilize it for real environment, really incoming data. Its inferencing is really where you will take advantage of the kind of models you have built so far. So basically, liveness of your services, Express AI services, really important. Okay, you guys are hearing me well?
Yeah.
Okay, thank you. And so I've been talking about, okay, so for this Express AI based service realization, okay, you have to accumulate a lot of data, but that accumulation data only will be possible when you are able to automate your overall kind of the process. So you will automate first, and then you can accumulate data. When you have the reasonable amount of data accumulate and properly labeled, you can utilize those data for your AI training. That's kind of the overall order, right? So autonomous and intelligent AI services is kind of the order. You will make it autonomous, kind of, then your services will become intelligent. So, but then we've been talking about the challenges behind, right? The data movement challenges, the data we are talking for example, large language models, it's really huge amount of data. So that is one big challenge, even though kind of the networking community like APAN is working on those, still it's too heavy, or it's too much to kind of say transfer the data reasonably and then utilize it for your AI training. Also, the other thing we have been hearing, the large language models kind of consist of more than billions of, can I say, parameters, which will require huge computing power, and that will cost too much money. And then even the availability of those kind of machines, even though you have money, is another issue. Okay, so everyone knows that they do have challenges, right? So overall, but the world is kind of undergoing some kind of changes to make it really supported. All this futuristic AI, the training and the live inferencing thing will be kind of enabled gradually. More and more cyber infrastructure being built, so it's growing, right? It's still growing, but it have to grow further. Okay. So this is kind of the same introduction basically to remind you about the term called Express AI services. Okay, DNA kind of concept is really important there. Then technically, okay, what will be really supporting infrastructure for that? Data-centric and cloud. Okay, basically we are cloud working group. So we've been talking about cloud is really important for you to be able to realize this kind of Express AI services, right? So then remind you about the data-centric thing is, okay, accumulation of the data is really important. Accumulation, but how it should be accumulated in a technical form, it should be accumulate in a term called data lake. People are using data warehouse or data lake and those terminologies. And the terminology is more towards going like maybe cloud scale, data warehouse, or like very large size data lakes, maybe connected data lakes. Here it means a lot of accumulated data will not happen in one place. All this distributed kind of say storage, data storage. Here the same similar or topic, or same similar say topic, data of a similar topic will be kind of stored together. Then they need to be connected so that overall it can be utilized when you want to train your AI model. Okay, that is basically big terms. So data lake is important there. Then people are also talking about the lake houses. So data lake with a systemic and AI analysis, data analysis, environment is something you want to build. And another thing, cloud native computing. So just kind of say to recall you about this, cloud native cloud thing is slightly different here, right? Cloud computing is more virtual machine based, while container oriented, container orchestrated services is cloud native computing. So cloud native computing is becoming kind of futuristic impact here. This kind of blue color, cloud native Kubernetes is say logo is really kind of say gaining momentum. Okay, so and when you are talking about express AI services realization, so in some form you may think of say IoT enhanced through with AI. So someone may call it AIoT, AI plus IoT thing, but overall all these containerized say small say, functionalities, someone may call it microservices. They will spread it over and they will connect together so that your express AI services will become existing in a manner of kind of scalability, in a manner to support scalability and also as well as space, affordability, because scalability and affordability is coming together. Okay. So actually this is kind of a new kind of conceptual slide to summarize all these trends. It's like say, so the other people kind of say the picture style thing, but basically here the main message here is that there are two main messages. One is okay, the Linux, okay, the penguin in the lower left hand corner, it means the penguins, they are kind of say manipulating, or they are kind of say, or what should I say? They are kind of owner of all these kind of say computer boxes, right? Linux is kind of the de facto one. Windows, Apples are very small, say minority in terms of computer systems or operating system, and that's one issue. The other one, cloud native computing. So this blue color, say Kubernetes thing is orchestrating another one. But also on the say upper right hand corner, you will see this kind of yellow kind of elephant is kind of pushing away those data, right? It's really heavy data, data warehouse, data lake, and then the lake house, all these things. But these are conceptual words, right? So basically, so in my school, actually, I belong to a school called Gwangju Institute of Science Technology, and then in the on the upper left-hand corner, you can see AI. Okay, this is A and I, but you have to know that I actually, in Korean word, I actually means small children. So AI, you can, in the logo, you can see the kind of say small boy standing, right? That's why we call this AI. This small standing for kind of rainbow color dream. So we call this as a dream AI. So basically dream AI thing is kind of really supported by these penguins and also Kubernetes thing. And then this kind of Hadoop originated, yellow elephant thing. Anyway, this is a conceptual one, but they are really becoming important. Okay, here one more word. Open source collaboration is becoming important there. So that the previous one very kind of pictures, but this is more kind of a little more technical and the reality one. So and at the core environment should be more data centric, should be more cloud native. All these basic principle and open source kind of leverage the ones will give us some kind of common platform. Here, common is important. Everyone kind of will share it, right? Penguins are open source, they have became popular for cloud native computing. Kubernetes is gaining a lot of momentum. Actually, this spring, they attracted more than 10,000 attendees for KubeCon. So it's a Kubernetes conference. This is a record number, so which means they are gaining momentum. So, but eventually what they are trying to do is they will provide a common platform for kind of the working with the futuristic AI-enabled, say, services infrastructure, right? So that common platform is a really big issue to us. So here, this common platform sense, it should be supported by the kind of your infrastructure, leveraging cloud data center, as well as your end or edge computing-based service realization. But these things are going and growing, and they are going towards something called the city scale live express AI services, to my personal interpretation. So you can see on the right hand side the big O. It's actually from NVIDIA Omniversing, the data twin kind of thing, incarnation from NVIDIA. It's basically what they are trying to do. So the keyword is kind of, what's important? Live express AI service realization, which will enable city scale, maybe digital twin style thing. The online simulation and offline experiment will be coordinated at the same time through AI technology. That seems to kind of one of the biggest kind of umbrella you can think of. It can accommodate, say, this digital twin thing. It may embrace the concept of a metaverse, say, thing, and a lot of things can be pulled into this big picture. Okay. So the summarization, which usually I'm trying to say, cloud native, data centric, kind of say, computing technology really behind that. So we need to pay a lot of attention for those. So let me switch to my final part on this. So part here, so let me switch it a little more on the side of high performance computing. So I just said in the beginning, I'm currently attending some domestic supercomputing conference in Korea. So high performance computing is gaining momentum, right? The large scale AI is really a big driver for that, right? Everyone here kind of know the sense of what is high performance computing, what is the large scale AI infrastructure, what is cloud. But they will share a lot of things all together. So it's important to know or understand how they are interacting, how they are growing together. So the sense of this kind of hypercomputing thing and the large scale AI thing kind of growing. Okay, I've been paying attention to this topic for some years. Okay, I've been drawing picture like the left-hand side, talking about, okay, with one cluster, you may be able to do computing intensive computing as well as data intensive computing and so on, right? That one is now it's kind of changed into this one. I'm not sure whether you can see my cursor moving here, right? So you can see HPC in one side, high performance data analysis and the other side, AI thing in the middle, right? This is kind of the three-way kind of say shape, but high performance computing, high performance analysis, and we'll share something for AI. This seems kind of three-way concept seems very much matching for current situation. So let me move on. So if you look at this thing, even the kind of supercomputing kind of community is undergoing. So exascale computers, supercomputers are being built and deployed. At the same time, collaboration originally originated from the grid thing is going on, but recently refactored into the new activities. So in the US, Exit is kind of say followed by Access is another say collaborative say computing collaboration thing. Place in Europe is continuing and so on. Basically, that trend is basically talking about cloud, say, leverage, APC and AI thing is growing continuously. So this concept on the APAN, we are also seeing a lot of working groups. Yes, we are now attending cloud working group thing, but you can also see a lot of this kind of say ID federations, say kind of working groups talk about how we should share ideas so that everyone can leverage, easily identify and easily give access to the proper authorized resources. So that kind of federate the usage of resources and commonality of say platforms, software is important. Of course, automation should be there. So this is another way of looking at this express AI realization, how it should be supported. Basically, the picture should be cloud resources, kind of not in a single say location, multiple location cloud, hybrid and it's multi-cloud and maybe even more kind of say structured, hierarchically structured, and which will be federated together. So this kind of federated cloud resource pool will be kind of say working together with all these edge-oriented say research site or edge-oriented kind of say smart X kind of say environment. Here, smart X means smart factories, smart digital farms, and so on, right? So that's the picture. So if you think of this logic, okay, what kind of infrastructure are you going to build for your say country's say future HPC and AI computing support? Okay, so inside Korea, we are also talking about this leverage thing, the national ones and the kind of say regional ones or specialized ones and some dedicated ones. You have to organize the resources, proper resource demand of your computing. So more leverage can be happen. Okay, here the cloud native software platform will be enabled, a key enabler behind this. So we are also undergoing to kind of say some changes to match this. And this is what fortunately, lucky enough to have some supercomputer, which was listed in Type 500 178 in the last November. Now it's 200 something. But it is there and learning for our kind of Korean community and also AI community all together. And so then what we are going to do, so I mentioned about the Live Express AI services. So we are trying to kind of say, put this as a kind of base backend, this kind of say computing server, so that more say the domain specific services, both services, okay, starting from kind of domain specific kind of say demonstration, pilot demonstration possible, more specifically kind of in the domain of autonomous driving and mobility and digital twin thing. We are going through that journey and okay, but here this data-centric and cloud-native computing paradigm is a really big enabler. All those things are giving us a lot of, kind of power to drive because driving for future, so better coordination is required, but this convergence of these things making our job easier. So I think Cloud Working Group is continuing some collaboration then, but the main thing is this kind of say cloud native based collaboration will be more futuristic and also this data centric, challenging. Yes, this is really hard one, much harder than the previous cloud native coordination. But anyway, the cloud native data center computing infrastructure built and then will be used as a common environment seems kind of something we need to work on together. Okay, this is the end of my talk. Thanks for listening. Yeah, thank you.
Yeah, thank you, Jong-Wan. Yeah. Any question to the speaker? Professor Jong-Wan Kim?
I'm not sure whether you guys
Any question to
don't have a problem hearing me. So it's a little bit noise. Sorry for that.
Yeah, that's all right. Yeah. Any question to all the speakers in this session? Yes, Andrew.
Couple for you, Eric. You mentioned the cryo-electron microscopes.
Yes.
Are they directly co-located with the HPC center, or are they distributed?
Could be distributed.
If they're distributed, what data transfer methodology are you using to pull the data off the microscope?
Yeah.
I think you mentioned, like our cryo people, they want a quick visualization of the mounting of the sample.
Yeah.
That streams back really fast. Once they know it's good, they hit the button and get the microscope to do the full scan. Is that the sort of methodology that your researchers are asking for at the moment?
No, we just use the open protocol. Yeah, open solution from the GFTP in the beginning and the SFTP. Yes.
Okay.
Yes.
What types of cloud software are you using? Is it OpenStack, OpenNebula, Kubernetes, or kind of a combination of many sort of
Combination,
techniques?
basically OpenStack and Kubernetes.
Okay.
Yes.
How does the earthquake data flow from the remote sensors to Academia Sinica? If everything, like if it's not a major network, I would presume that you've got the communications lines in place.
Yeah.
But if it's a major event, how do you actually get the data up from the field over to Taipei?
Yeah. That's already embedded in the sensor.
Okay.
Yes.
So
now they are using Raspberry Pi.
Okay.
Like a very simple computer together with a sensor. So the computer will take care of the data transmission to the destination.
What medium are you using for the data transmission? Is that fiber or is it wireless, or how do you actually move the data?
Yeah, the IE network infrastructure in Taiwan.
Okay.
So that's basically the fiber. Yes.
What software are you using to build the big data and AI portals? Is there a particular portal software that you're using, something like Open On Demand, or is it something you've developed yourself?
Nothing particular.
Okay.
Yeah.
I think that's all my questions. Thanks, Eric.
Thank you so much. Yeah. Any other questions? Question to the speaker or question to the working group? Yeah. Advice for the arrangement of the future activity, or you like to share your case study or anything in the future event or in the next session, all are very welcome. Yeah. Yes, please.
I'm from Sri Lanka. I'm from Sri Lanka National Science Foundation. I would like to know, is there any data repository kind of thing we are going to have in Sri Lanka, or have you already have a mechanism? Because there is no any common place to store scientific data for the future use. That's why we are thinking of having a common center to host the scientific data, which is already sometimes we also funding many researchers to do research, but their research data is not available in a common platform.
Yeah. Let me explain by the system architecture from our center. What I like to say, sorry. in short, that's based on the requirements from the user community. That's because different user group they might use for their data repository, yeah, in the beginning, yeah. So the direct way, the fast solution is how to enable their existing directory accessible to all the users, to all the community in different institute. That's the first. So that's should be not decided by the cloud service provider, but by the user community. If there is no solution yet, so basically we just providing the system such as NFS or a safe system or Lustre or anything. We can provide the basic sharing file systems. Then we have to work together with the user community to build up the services upon that. Yeah, that's the basic architecture. And probably
able to enable with them to provide hosting services for institutions like us, especially.
yeah. So the best way is to work with you together. Yeah, we can supporting our sharing our experiences, supporting you to establish services in Sri Lanka. Yeah, if there is any collaboration opportunity, for example, just for example, for the disaster mitigation or earthquake collaborations, then we can see how to share in those data and the services among the user community in our countries. Yeah,
Unified. Yeah.
yeah,
Thank you.
yeah. So I keep emphasize the requirements from the user community because that's the key point. Yeah. So all the cloud services, that's all to meet the requirements in the best way. Yeah.
Correct. Thank you.
Yeah. Thank you. Any other questions? You know, the next session is open for discussion. So if you like to share anything, yeah, please just let me know. So in my talk, yeah, actually, I think collaboration with different working group in APAN that provides very good opportunity for us, yeah, to work together to achieve more. Yeah, that's at least that's a starting point. Many available, easier access resources already there. Yeah, as I mentioned here, for the from the single sign-on to the cloud deployment, to the application sharing, to the data sharing, to the application support, and also, of course, the infrastructure from networking, routing, security, many things. Yeah. So if you stay here for the whole week, it will be very useful to join the working group meetings to understand what they are doing and if there's any good opportunity to work together. Yeah, that's our suggestion. So as a chair, sorry.
One thing,
Yes.
actually, National Science Foundation is the Center for Dissemination of Scientific Information in the country.
Yes.
Basically, we are catering to our scientific community for the last 54 years.
Yeah.
Unfortunately, we are doing only posting of our research data, especially publications. And we have several digitization programs and all. But we have not been working with APAN to have collaborative programs to expand our services.
Yes.
By looking at what you have been done in your organization, in your countries are very much different from our culture, because the services available for our community is very limited, and knowledge also how big data can be stored and shared and analyzed on our developments of the country, or maybe future use of our scientists.
Yeah.
So this area we have to have a very good collaboration and awareness how we can get this service to Sri Lanka.
Yeah,
I
it's
think
our great pleasure if there's anything useful from our experiences or from the resources of the APAN working group. Yeah, we are very, very happy to work with you. Yeah, for sure. Yes, Andrew.
As Eric mentioned, we've been
As Eric mentioned, APAN has been on this journey for the last 2 decades. Please take the stuff that we learned works well, and we can tell you all of the things that we didn't get right along the way. So you're in a good position to pick up the Open and Sharing Data Working Group. It's probably the one you're going to want to attend most in this session.
I don't remember the exact schedule of the Open and Sharing Working Group meeting. Yeah, please check check the HOVA. Yeah. So Hiroki, do you have any comment, or Jongwan? We still have 3 minutes, I think, for this session.
Yeah. Okay, so it is not only that today's meeting, but by the way, so I hope, so in the next meeting, I hope to gather or so invite some. I have already mentioned in my presentation, but I want to so in these so 52 or 53 APAN Cloud meeting consists of the very fixed members, so including I and Eric and John Won. So it's not so so better things. So I want to change, or so yeah. I will so invite some other researcher according to the cloud computing or any kind of the edge computing or anything else. Yeah, I will try to. Yeah, okay, that's all. Thank you very much. And how about you, Jomon?
Yes, Jongwan.
Yeah, sorry, yeah. I was not able to concentrate on the discussion, but yeah, so due to COVID, we was really kind of say, not really able to concentrate, right? Yeah. But now things are coming back to normal, and the people are doing more cloud things. Actually, I also see more momentums, let me say more industry connected momentums are happening. Yeah, surrounding HPC and actually AI and the cloud. So that kind of experience, how to collaborate with the kind of let me say PPP collaboration, private, public partnership, that kind of concept. We can talk more on those. Yeah, let's try to make a much more organized one. I believe I cannot hand that one offline at the end. So this time, But anyway, the world is changing, around the cloud. That's what I can say,
All right.
Okay.
Thank you. Thank you so much. If there is no more comment or any, yes.
Yeah, I just would like to ask about the digital twin that presented in the last speakers. Actually, I think the infrastructure is one issue. The technology of platform is another one. But more important is about the data.
Yeah.
So I would like to know, do you have a real example or use case of the digital twin based on what you have presented? Maybe the speaker can answer or give the example. Thank you.
Go on.
Oh, so the data about the question about data, actually, so we are also in the beginning of kind of processing or gathering people interested in the mobility simulation in Korea. And one of main hurdle is really data thing. the size of data. Fortunately, we have some size of storage we do have a storage size of 10 petabytes, which is reasonable enough to collect some amount. But the main challenge is really the data for collaboration. It's everyone don't really want to share the data right away unless there is an ultimate reason for that. The challenge there also kind of sharing really technical things behind the security, privacy, and also transfer kind of costs. Because of security, transfer cost increases, and then that also blocks us a lot. So many times delays are happening because of that. So anyway, data is the hardest thing, as I commented in my talk. Okay, that's it.
Thank you. Okay, thank you. I think it's time to end the first session. Thank you so much for your participation. And please back at 11:30 for the second session for discussion. Thank you so much.
Thank you.